video I wanted to talk about translations. So what is a translation? Well, a translation is something that you do to a function to move it right, left, up, or down. Okay, so let's say we have this function here, okay? If we moved it right, or if we moved it left, if we moved it down, or up, or even right then up, right? Those would all be considered to be translations, because you're just moving it around that Cartesian plane. In the future, we'll talk about different types of what they're called as transformations that do different things to functions. But for now, we're just going to talk about translations and moving them around the Cartesian plane. Okay? So how would we actually do this if we were dealing with an equation? Okay? Since we had the function 3x, okay? Let's say we have that. It would look like this, right? If we wanted to move this right by 2 units, what would we have to do to the equation? What would the new equation look like? So this is f, this is, let's say, g, okay? So g of x is going to equal something, but we don't know yet what it is yet. So f, we know, is going to be 3x, right? So the function is always going to be 3x, okay? And for example, at 0, at the point x equals 0, y is also going to be 0, right? Because 3 times 0 equals 0. So we're plugging in the x value of 0 to get the y value of 0. Now what about, let's say we have the x value of 1, okay? So if we dotted our line up here, what would our y value be? Well, our y value would be 3, because 3 equals 3 times 1. Every time we're multiplying 3 by our x value. Now how does that work out for g? Well, g, that definitely does not work, okay? Because if we have our value 2 here, for example, and let's say we multiplied it by 3, so 3 times 2, that is definitely not equal to 0. Definitely not, right? Okay, but let's say let's do another one. Let's say we wanted to get the value 3, because y is 3 here. Our value here would be 3. So 3 times 3 is definitely not going to be equal to 3, right? Definitely not. So when we're multiplying these different things by 3, it's just not working, right? Because we're plugging in the x values that have been shifted to right. It doesn't work. But what can we do to fix that? Well, if we shifted these values to right, and when we really need a value that's much smaller to be multiplied by 3, what if we shifted them back to left? So what I mean by that is, what if we did 3 times x minus 2 is g of x, okay? And what is that really saying? Well, you're basically saying that for every x value, you're going to go back to and then get that value. So for example, at the value of 2, you're going to go back to over here. You're going to say, okay, I'm going to multiply 3 by 0, and then you're going to get that y value, and you're going to put it there. So what I really am trying to say is, since we moved this up 2 units, the x value that is here, for example, 2, is not going to output a 0, right? So what we have to do is we have to subtract 2 from it so that what we're multiplying by 3 is equal to 0. So instead of 3 times 2, we're going to say 3 times 2 minus 2, right? We're going to subtract 2 in order to offset it so that it's back to 0. The same as here. The x value is clearly too big to get you your correct value. So you have to subtract that value. And what happens if we moved it left? What would happen if we moved it left? Well, this function here, let's say we moved it back 3 units. We would actually have to add 3 units to the x value. So it would have to be 3 times x plus 3. And the reason for that is for every single x value over here, it would be -3, it would be too small. Every single x value would be too small to input into our normal function. So we have to change our function so that we increase the x values by 3, exactly how much we shifted it by. Or let's say we moved it back -4, right? Then we would have to add 4 because we shifted it even more. So we have to fix it even more. We have to fix these x values so that they're at the point where they need to be in order to have the correct output, a bigger output. So at -3, 3 at -3, it has to be, so 3 times -3 isn't going to equal 0. What we have to do is we have to say 3 times -3 plus 3 to offset the decrease that we did before. So let's try an example, just in case that was too complicated. Okay, so let's say we have the function 4x, okay? Not a lot different than the previous function we had. And the graph would look like this. It would be the same as our old function, but it would be a lot steeper, right? It would be steeper. And let's say we wanted to move it left 2 units, okay? If we moved it left 2 units, every single x value here would be 2 units less than what it needed to be. So 4 times 0, this is our usual function, is going to equal 0. But 4 times -2 is not going to be equal to 0. So what are we going to have to do? We're going to have to add 2 to our x value every time. So our new function is going to have to be 4 times x plus 2. We're going to have to add 2 to every single x value along the line in order to have a function that actually outputs the correct y values. Okay? Alright, so that pretty much covers moving left and right. But what about moving up and down? What would the equation look like then? Well, let's say we had a function and it was equal to 4x again. Let's just do 4x again. And let's say we wanted to move it up or down. Okay? Alright, let's say we wanted to move it down 3 units. Okay? Whoa, that does not look good. Okay. Say this is what it looks like now. Okay? It's been moved down 3 units. Sorry about the bad drawing, but it's been moved down 3 units. Okay. How are we going to deal with that? Well, this is actually a lot easier than moving it left and right, in my opinion. So we know that saying f of x equals 4x is the same thing as saying y equals 4x, right? So if we wanted to decrease y, right, because that's basically what we're doing, for every point, so for example here, this y is going to be decreased by 3 units, right? And if we're comparing this line and this line over here, this y is going to be 3 units less than this line, and so on. So how would we decrease our y value? Well, we could just say y equals 4x minus 3, okay? We want to decrease our y value by 3, or if we wanted to move it up by 3 units, we would say y equals 4x plus 3, because we're increasing our y value. Okay? Alright, now there's an important thing that you guys need to keep in mind when you're doing these questions. When you're changing an x value, so let's say we had a function 3x cubed. If you wanted to change that x value, you would have to change the x value only to move it left or right. So let's say we wanted to move it right by 2 units. We would have to rewrite that function as 3x minus 2 cubed. Okay? 3 x minus 2 cubed, okay? We would have to put that new x minus 2 in brackets because it's replacing your x. Now, if you were to want to change, if you were to want to decrease the y value, if you wanted to decrease it and make it go down, then you would rewrite it as minus 2. You're subtracting 2 in order to make that y value go down from the whole function. You're not going to decrease the x value, you're going to decrease the whole function. Now that's important to keep in mind. But that pretty much wraps up translations. Next video we'll be doing stretches and reflections. Hopefully you found this useful and interesting. Thank you.